So here we have a projectile word problem. It says Jacob shot a model rocket off the top of the 2000 building. The equation h of t equals negative 16t squared plus 40t plus 100 describes the height, which is our y value of the rocket, after t seconds, and that's our x value of our rocket. And it asks us to do a number of different things. The first thing it would like us to do is to graph the equation, labeling the axes. So I'm going to go ahead and graph this equation the way I normally do. The first thing I'm going to do is I'm going to find the vertex, negative b over 2a. So b is 40, and a is negative 16. And that gives me negative 40 over negative 32. And I know a negative divided by a negative is positive, so this number is positive. And if I reduce that fraction, I find that the x value of my vertex is 5/4. That's my axis of symmetry. So let's go ahead and substitute that back into our equation and find the y value of our vertex. And all I'm doing right here is putting in 5/4 for x. And now I'm going to square 5/4. That gives me 25 over 16. And now let's do this multiplication. If I go ahead and divide that, that becomes negative 25. And again, I can go ahead before I multiply, I can simplify these fractions, dividing that by 4 and that by 4. So this ends up to be 50. And that ends up nice because I've gotten rid of my fractions. So negative 25 plus 50 plus 100 is 125. So my vertex is at 5/4, comma, 125. And I'm going to go ahead and put that on my graph. But the one thing I notice about my graph is it needs to be renumbered. If you take a look at the numbers 2, 4, 6, 8, and so forth, on my y-axis, I need a number as big as 125. So I'm going to call each one of these lines 10. So this would actually be 20, 40, 60, 80, and so forth. And then notice in the problem it says you're supposed to label your axes. So this is time, and I need to make sure and label that so I'm communicating clearly. And this is height. And my vertex goes at 5/4, comma, 125. So there's 120, 125 would be right there. So I know that point on my parabola. I also happen to know that it intersects the y-axis at 100. That's given to me in the equation right here. That constant value is going to be my y-intercept. So the next thing I need to plot is one more point to give me the shape of my parabola, and what I'd like to plot is my 0. I know I'm going to have part of the parabola doing that and the other part of the parabola coming down like that, and I'd like to know specifically where. So I'm going to go back to the original equation, which was negative 16t squared plus 40t plus 100, and I'm going to factor. And I notice I can factor out a negative 4, that changes the sign. And now I know I'm looking for factors of negative. Well, hang on just a second, let's get this right. There we go. 4 times 4 is 16, 4 times 10 is 40, and 4 times 25 is 100. There. Now I've factored out my GCF, and I'm looking for factors of negative 100 that add up to positive or negative 10. And I can't find any. When I factor 100, my factor pairs end up being 1 and 100, with one of them negative, 2 and 50, 4 and 25, 5 and 20, 10 and 10, and none of those are sorting out to give me what I really need in terms of factoring this equation. So I come to the conclusion that we're just not factorable. And I'm going to have to drop back to my quadratic formula to find the other 0. So I'm going to grab this equation, and we have negative b plus or minus b squared minus 4 times a times c all over 2 times a. So I have to sort out what's underneath my radical sign, my discriminant first. So 40 squared is 1600, and 4 times negative 16 times 100 is negative 6,400. So since it's negative, that changes the sign there. Over negative 32. So I go ahead and add these and take the square root, and I get negative 40 plus or minus 89 approximately over negative 32. And so I need to split that into my two equations. Negative 40 plus 89 over negative 32. And negative 40 minus 89 over negative 32. And I go ahead and do my arithmetic, and this gives me negative 1.5 approximately, and this gives me about 4.03, I believe. We're going to graph that as approximately 4. So I found that on this side of my graph, I'm going to go through negative 1.5. And there's one of my zeros at negative 1.5. On this side of the graph, I'm going through just about 4. And I can finish sketching my parabola. So if we jump back and we look at the requirements of the problem, the first step just said graph the equation and label the axes, and I've done that. I've found my vertex, my zeros, my y-intercept. I've put the parabola on the graph, and I've been very clear about what I'm graphing on x, what I'm graphing on y, and what my scale is here on the y-axis. So it says find the maximum height of the rocket. Well, right here at the vertex is my maximum, and remember our y value is height. So the rocket reaches a maximum height of 125 feet. And then it says after how many seconds does it reach that height? And remember our x is time. Since we're graphing time on the x-axis, this tells me that we reach 125 feet after 5 halves of a second. Excuse me, that's 5/4. 5/4 of a second. So our maximum height is obtained after 5/4 of a second, or just a little more than 1 second. And that maximum height is 125 feet. So we've graph the equation, labeling the axes. We've found the maximum height of the rocket, that's the vertex y value. We've found the number of seconds it takes to reach that maximum height, which is our x value. And then the last question says, when does it hit the ground? And that's this guy right here. It is our zero that we found. So it hits the ground after approximately 4 seconds. Another good question that isn't stated in this problem, but many projectile problems will ask you this, is what is the height of the platform that it was shot from? So we shot the model rocket off the top of the 2000 building, and this constant value right here of 100 tells you how high it was before it was shot off. So we would say 100 feet if we were asked that question.